Okay, so if we scroll through, this page just has some notes on it. So that we just saw the equation for force due to gravity is F is equal to mg, right? So F is equal to mg. But that is just assuming that we know g already. So on Earth, we know it's 9.81 meters per second squared. The thing is, where that came from. So previously I told you that it is based on the mass of the Earth plus the radius of the Earth. So I have g is equal to, so this is our new equation from Sir Isaac Newton. Force of gravity is capital G multiplied by the mass of object 1 multiplied by the mass of object 2, and we're divided by the distance between the centers of those two objects. So usually what we're looking at is we have some planet Earth, sorry, horrible circle. So we have some planet Earth, and you might be standing on that planet. So in this case, r would be the distance from our centers. The distance from our centers. Big M would be the mass of the Earth. Little m would be the mass of the thing we're trying to do. The other objects, in this case u. And g is a universal gravitational constant. So it's based on our universe. This is what it is. There's no understanding where it came from. This is just the constant of the universe. This is just what it was discovered to be. So the value of it is 6.67 times 10 to the negative 11 newtons meter squared per kilogram squared. This is given to us on your formula sheet. Okay. And if we just plug our values, g times the mass of our two objects divided by the r squared, that will give us the force of attraction between them. So we have to be careful with this one. This is not always just like radius. We put an r there because usually it is radius from some center of an object, but this can work between any two objects. So for example, if I have like the sun and the earth way out there, if I want to find gravitational force of attraction between the sun and the earth, it's the distance from the centers, from the center to the center. Okay. These two graphs basically show us the relationship between force and mass. So what we can see, it's a linear relationship for mass. So as mass gets bigger, force will just get bigger linearly. So you can write it as force of gravity is proportional to mass. However, because we are dividing by r squared, as r gets bigger and bigger and bigger, force of gravity gets smaller and smaller and smaller. So we get this what's called a reciprocal relationship, also known as inversely proportional to the square of the distance. So the next we'll do some calculations with you.